All right, let's look at what we've got to do here. We've got to balance this chemical equation. We've got to put in states of matter, which means we've got to say whether things are solid or liquid or whatever. We've got to write the complete ionic equation, find out what the spectator ions are, and then write the net ionic equation. Not too bad. Let's start by balancing the equation. First of all, how many sodiums do we have? There's one here and one here. So those are already okay. The chlorides, likewise, 1 and 1. So those are fine. Silver, 1 and 1. Those are also okay. Nitrate you can look at as a single piece. You don't need to split it up into nitrogen and oxygen. So nitrate over here and 1 nitrate over here. So this equation is actually already balanced. And number 1 is done. At least that part. Put in the states of matter. That means that we've got to identify whether these things are dissolved in water, which means that they will be aqueous, or whether they're solid, in which case they will be written as solid with an S. NaCl. Well, that has an Na in it, and it also has a Cl in it. Those on solubility tables mean that this is going to be aqueous. AgNO3. Ag is bad for solubility, but nitrate NO3 is really one of the best there is. So this is going to be aqueous. AgCl. Ag is bad for solubility, and Cl is actually is good for solubility, but lists Ag as one of its exceptions. So this is going to be solid. NaNO3. Sodium is good, and nitrate is good for solubility, so this is going to be aqueous. So now we found the states of matter. Write the complete ionic equation. This involves taking the ions and writing them out individually. Na plus and Cl minus. That gives you the dissolved sodium chloride. Now we're going to write the rest of the ions. Ag plus oop, that's a minus right there. The ionic equation tends to take up a lot of space. But here, I'm going to write the AgCl in its full form because it's not split up. It's dissolved. For the same reason that it's solid, it's not split up, it's not dissolved. And then I will add the others on the right side, which are dissociated, and therefore I will write them as ions. We've written the complete ionic equation. Now we have to identify the spectator ions. In green, the spectator ions are the ones that stay the same. So, the ones that stay the same are the sodium, right? And the nitrate. The reason that I say that they stay the same is when the reaction proceeds, which means that it goes from left to right, the sodium is unaffected, and the nitrate is also unaffected. They both stay. So the spectator ions are Na plus and NO3 minus. If you want to write the net ionic equation, this is without spectators. So because the spectator ions do not participate in the reaction, they do not react. The net ionic shows only the ions that actually do something. It's a compact way of writing what's happening in the equation. Well, if we look at this and we say, okay, well, we're going to get rid of the sodium and we're going to get rid of the nitrate, what's left over is these two. And of course, on the right-hand side, the product of them mixing. Writing plus first and minus second, this will be Ag plus aqueous plus Cl minus aqueous yields AgCl solid. And this right here is the net ionic equation. Cool, huh?